Right now, unless you're somehow watching this from space, you are situated on a planet, a giant sphere of material and heat. Ours is made mostly of rock, as are the 3 other planets in our backyard. Further away from the Sun lie 4 huge balls of hydrogen and helium in different states. These constitute the 8 planets of the solar system, 4 rocky terrestrial planets and 4 gas giants. However, this is far from the full picture. The solar system is also home to another type of world. Between and beyond the orbits of the 8 conventional planets lie dozens and dozens of small icy worlds, orbiting in the outer reaches of the solar system. These are known as minor planets, or at least they used to be. The best example is, of course, Pluto. In 2006, Pluto was reclassified as a so-called dwarf planet, voiding its status as the solar system's 9th planet, which it had held for many decades. Pluto ultimately is just too small to be considered on the same level as the Earth or Saturn. However, there is more to it than just Pluto's size. The actual story behind Pluto's reclassification started with the discoveries of several similar remote minor planets. And now, Pluto sits among a family of almost worlds, dwarf planets, which despite being much smaller than the Earth, still exhibit fascinating and unlikely properties. Today, we will experience these frozen, far-out worlds firsthand. The term minor planet is a broad classification, defined as any astronomical object in orbit around the Sun or another star which is neither a planet nor a comet. Most of the time, this is because it is either too small to be a planet or it doesn't have the same impact on its surroundings as the other planets do. While Pluto is the obvious one, there are almost 800,000 known minor planets in the solar system alone, which are archived by the Minor Planets Center. Up until about 15 years ago, the terms minor planet, planetoid, and asteroid were all used synonymously, referring to a body not large or round enough to be considered a conventional planet. However, since the term was coined, we have reached and studied the outer solar system, a place where rocky and icy material is much more abundant, leading to discoveries which have blurred the lines between what can be considered a planet and what can't. As a result, the terminology has become more complicated over time, and the need for clarifications arose. And so, in 2006, the International Astronomical Union voted to amend their definition of a planet. Before this, a planet had to satisfy 2 simple criteria. The first being that it needs to orbit around the Sun, obviously. The other thing is that it needs to be in hydrostatic equilibrium. In other words, large and heavy enough that it becomes rounded by its own gravity, giving it a spherical shape. Under these criteria, Pluto was discovered and named the solar system's 9th planet, which it remained for many decades. But with the definition change came a third criterion. Now, a planet must also clear out its orbital path. As they travel around the Sun, the large planets either clear out or consume material in their way, dispersing the rubble of the early solar system, and clearing themselves a region of space which they dominate and influence. Under this revised definition, however, Pluto doesn't fit the bill. The reason being because it orbits within a large band of debris near the outer rim of the solar system, and thus doesn't clear out its region of space. Thus, it lost its planetary status, to the disappointment of many. Following the rule change, the IAU then reclassified the term minor planet into 2 new subcategories: dwarf planets and small solar system bodies, or SSSBs. Dwarf planets, like Pluto, are the nearly worlds, which are large enough to be rounded but don't dominate their surrounding space. A small solar system body is anything else that isn't a comet, like a large asteroid, or the microsatellites which orbit such asteroids, or perhaps the icy objects beyond the reaches of Neptune, known as trans-Neptunian objects, or TNOs. As a result, the term minor planet has become outdated, but it is still used to encompass both types. Today, however, we are going to be focusing for the most part on dwarf planets. While not as large or structured as their planetary counterparts, they can still house astounding properties, the likes of which we never expected to find on worlds so far away from the Sun. And while most of these worlds lie billions of kilometers away and are thus very difficult to reach and study, we do have one relatively close to us, the first dwarf planet ever to be discovered and visited, Ceres. Ceres was discovered in 1801 by Giuseppe Piazzi, who noted it while he was searching for stars. Initially, he mistook it for a comet and named it Ceres Ferdinandia. However, within a year, astronomers had identified it as another planet and shortened its name to Ceres, named after the Roman goddess of corn and harvests. It lies over 400 million kilometers away from the Sun, within the asteroid belt, a ring consisting of pieces of rock between the orbits of Mars and Jupiter. After initially being mistaken for a comet and then for a planet, Ceres was reclassified as just another asteroid among the many others in the belt. However, it sticks out as an outlier against its rocky neighbours. At just under 1,000 kilometers in diameter, it is by far the largest object within the belt, and also accounts for about a third of the belt's total mass. And so, it was among a host of objects to be reclassified as dwarf planets in 2006. Putting aside the anthropocentric terminology, however, it seems strange, doesn't it? A dwarf planet here in a sparsely populated belt, where nothing else like it exists, too large to be an asteroid, but too small to be another planet. And so, in 2015, we visited the world in an attempt to better understand its origins. NASA's Dawn spacecraft made flybys of Ceres, sending back detailed images and giving us clues to its past. It is composed of mostly rock and water ice. Its core and mantle are thought to constitute a layer of ice which, if it exists, would mean that Ceres has more water than the Earth, in a solid form at least. But buried beneath its icy, cratered surface, it is thought to have pockets of liquid water, surviving from a subsurface ocean which once flowed above ground on the surface of the dwarf planet. It is now thought that Ceres is the remains of an embryonic planet, a small rocky body which was accumulating material in the early solar system, just like the Earth. It is now believed that Ceres may have had an ocean of magnesium salt water flowing on its surface billions of years ago. However, its destiny was cut short when its neighbouring planets, Jupiter in particular, scattered and consumed the vast majority of material in the area, the same material that grew the terrestrial planets and the gas giants. As such, Ceres was unable to grow larger, and so was far too small to hold on to its primordial atmosphere. And so, the budding protoplanet died, and was cast into the asteroid belt, destined to float silently among rubble and debris. When its atmosphere was lost to space, so too was the ocean, and its remnants are now buried beneath the surface in its last surviving pockets. We can see evidence of these liquid water pockets in these shiny bright patches on the surface. These highly reflective mounds are actually deposits of magnesium salt residue, left over from liquid water eruptions in the mantle, which spilled out onto the surface. Whether anything could survive in these underground pockets of water remains a mystery. One thing's for sure though, Ceres is a true gem, hidden within a dead and desolate region of the solar system. One of the reasons there aren't any other dwarf planets in the asteroid belt is because the belt is so sparsely populated. Most of its material has been depleted, and the few objects that remain are scattered millions of kilometers apart. However, significantly further away than the asteroid belt, beyond the orbit of all 8 of the planets, lies another far larger belt of material, the Kuiper Belt. The Kuiper Belt is a thick, rotating disk of icy objects and debris, similar in structure to the asteroid belt, but much larger and more densely populated. The objects in the Kuiper Belt are thought to have formed very early on in the solar system's life. rocks began appearing out of the dust around the young sun, which condensed to form the planets, and any primordial rocky pieces that were not consumed were scattered, and much of it drifted and settled into this massive belt unfathomably far away from the sun. Because the objects within are so far away from the sun's light, they have only been warmed and irradiated slightly in the billions of years since their formation, and so are thought to be well-preserved artifacts, which can allow us to examine what the solar system was like back then. The Kuiper Belt begins at just beyond the orbit of Neptune, around 30 astronomical units away, so that's 30 times further than the Earth is from the Sun, and it extends out to around 50 times further away. Thus, it is so remote and vast that it is a place that we have only just begun to explore and understand. Objects within the Kuiper Belt are referred to quite simply as Kuiper Belt objects, or KBOs. Scattered within the Kuiper Belt's expanse are hundreds of millions of cometary nuclei, hundreds of thousands of objects larger than 100 kilometers in diameter, and perhaps hundreds of small, cold dwarf planets which have yet to be discovered. And crucially, because they all exist and orbit within the bounds of this belt, they do not clear out their orbital paths or dominate the space around them, effectively excluding them from being planets. However, that doesn't stop them from having intriguing planet-like features, such as transient atmospheres, which exist as gas in an atmospheric layer when faced with the light of the sun before collapsing down into frost on the surface during the night. This brings us to our most distant honorary planetary neighbour, Pluto. Pluto was discovered in 1930 and it is named after the Roman god of the underworld. It is classed as a Kuiper Belt object and a dwarf planet today, but it was long considered to be the solar system's 9th planet. It is smaller than all 8 of the solar system's main planets and orbits considerably further out, averaging a distance of about 39 astronomical units. It orbits the Sun in both an elliptical and tilted orbit, which can take it as far away as 50 astronomical units, to the very distant outer edge of the Kuiper Belt. Its small size, low visibility and sheer distance from the Earth makes it a very tricky world to study. Until about 5 years ago, we only had very low detail observations of the dwarf planet, but all this changed in 2015 when NASA's New Horizons mission flew by Pluto, revealing it in brilliant detail for the first time. And what a revelation it was. The data we've collected from Pluto since has revolutionised our ideas on the complexity of worlds this far away from their parent star. Despite being small at around 2,370 kilometers in diameter, Pluto still has a surprisingly detailed and mysterious landscape, consisting of vast mountain ranges made of solid ice, some several kilometers high. It also has valleys, craters, flat plains, and even ice caps of frozen methane. It is thought to have a rocky core surrounded by a water ice mantle topped by an icy crust. Because it is so far away, its surface temperatures can fall to as low as -240 degrees Celsius, so cold that nitrogen and methane gases freeze down onto its surface and into frozen nitrogen ice sheets across its vast plains. For the most part, Pluto is a scarred, cratered world, except for in one unusual place, like nowhere else found in the solar system. For this, we have to look to the Tombau region, also known as Pluto's heart. It is a large, double-lobed plain of smooth volatile ice sheets. Its western lobe is known as Sputnik Planitia. Here, there are no impact craters. Instead, the smooth icy surface is intersected by cracks which crisscross the ice sheet, showing evidence of convection currents below the surface. Even at this size and distance from the Sun, part of Pluto's crust is active. We're not sure exactly what drives this convection, but it is responsible for gently turning the nitrogen ice sheet over, resurfacing it and keeping it fresh, thus explaining the lack of craters. One theory is that this active nitrogen ice sheet floats atop a buried subsurface ocean of liquid water that has existed for billions of years, which was exposed by a huge impact collision. This collision would have torn off a huge chunk of Pluto's crust, resulting in radioactive decay within the basin it left, which may be the elusive heat source that is churning the ice sheet to this day. During the day, Pluto's volatile ices sublimate directly into a gas, which expands into an atmospheric layer of nitrogen, methane, and carbon monoxide. Because it has such low gravity, its atmospheric layer is held down much less tightly than it is on Earth, allowing its atmosphere to extend much further out into space. And as the New Horizons spacecraft flew away from Pluto, it turned back and saw this inflated atmospheric layer in all of its breathtaking glory. Pluto also has no less than 5 moons. The largest, Charon, is about half the size of Pluto itself, making it the largest moon relative to its parent in the solar system, and also one of the closest. So close in fact that the gravitational centre of the Pluto system is not actually Pluto itself, and thus Pluto and Charon are generally referred to as a barycenter. The other 4 moons, Nix, Hydra, Styx and Kerberos, are all much smaller, resembling fragments more so than moons. We're not sure how the Pluto-Charon system came to be, but the leading theory is that it was formed by a collision of Kuiper Belt objects. Pluto and Charon have similar densities, which suggests that they may have once been part of a single body. For now though, that remains just a theory. We talked earlier about the IAU's reclassifications in 2006, but what actually was it that prompted the debate between what constitutes a planet or not? It wasn't Pluto itself, because Pluto was accepted as a planet for a long time. It was actually a series of minor planet discoveries between 2003 and 2005 that were what got people questioning the definition. These discoveries were made by Mike Brown at Palomar Observatory, and in the years leading up to the IAU's decision in 2006, he identified 3 new dwarf planets lurking beyond the orbit of Pluto in the Kuiper Belt. These worlds were Eris, Haumea, and Makemake. At present, none of these worlds have been visited, and so these far-out images are as close as we've managed to get. However, we have been able to deduce and ascertain some of their properties by using techniques such as spectral analysis. Of these 3 newfound dwarf planets, it was Eris that caused the stir. Eris is the second largest dwarf planet in the solar system after Pluto, but it is also the most massive. It is estimated to be about 2,326 kilometers in diameter, only about 50 kilometers less than the dwarf planet's sibling, and so virtually the same size when viewed on a global scale. Scientists think that it is probably rocky and icy, with the terrain similar to the one found on Pluto. It was first spotted by Brown in 2003 and was later confirmed in 2005, and when it was set to be classified as the solar system's 10th planet. However, this raised an interesting dilemma. If we allow Pluto, Eris, and any other dwarf planets to be planets, then before long the solar system would have 20 or 30 planets, the vast majority of which would just be rounded Kuiper Belt objects. And so, this led to the addition of the 3rd criterion in the IAU's definition of a planet, effectively excluding all Kuiper Belt objects from consideration. Both Pluto and Eris were classified as dwarf planets, and Eris was named after the Greek goddess of strife and discord. We don't know much about what its surface is actually like, purely because it is so far away. It is over 3 times further away than Pluto, and its orbit takes it far beyond the Kuiper Belt, to the cusp of interstellar space at almost 100 astronomical units away. Because it is so far away from the Sun, gases like nitrogen and methane will have almost certainly frozen down onto its surface like they do on Pluto, so perhaps the 2 worlds are more similar than we yet realise. One thing we do know for certain though, is that Eris has one small moon, named Dysnomia. It has a nearly circular orbit around Eris, completing a lap of the dwarf planet once every 16 days. This satellite has allowed us to make estimations of the dwarf planet's mass, which is how we managed to conclude that it is more massive than Pluto, and thus the most massive dwarf planet in the solar system. But unfortunately, that's about it, and it will probably be a while before we can get any closer, as this world is so far away and remote that, at present, it is simply too far beyond our reach to study up close. The second dwarf planet discovered by Brown was Haumea. It was first noted in late December of 2004, originally being nicknamed Santa, before being officially named after the Hawaiian goddess of fertility and childbirth. It is about a third as massive as Pluto, and it's hard to know whether to class it as a dwarf planet or a small solar system body. Unlike the others mentioned so far, it is not a spherical world. Instead, it has an elongated egg shape, estimated to be around 1,600 kilometers in diameter. Its rapid rotation and high albedo are clues as to its origins, and we now believe that the minor planet is perhaps the largest constituent of a collection of trans-Neptunian objects left over from a large collision of debris. Before this, Haumea was perhaps a rounded world more analogous to Pluto and Eris, but this collision is thought to have blown off Haumea's icy mantle, resulting in a relatively unstructured and unshapely body composed of silicate rock. We cannot make out the surface in much detail, but its colour changes as it rotates relative to us, indicating that there is a dark patch on its surface, like on Pluto. It also has two very small moons, Hi'iaka and Namaka, which are also thought to be remnants of the same collision. But perhaps its most unusual and captivating feature is that it has a faint ring around it, making it the first trans-Neptunian object with a ring system to be discovered. The ring's width is about 70 kilometers, and it extends the system's total diameter to around 2,300 kilometers wide. Pretty impressive complexity for such a small, immature world. Finally, we have Makemake, the third dwarf planet to be discovered by Brown in 2005. It is slightly smaller than Haumea at about 1,400 kilometers in diameter, but unlike the former, it is rounded by its own gravity. While small, it is the brightest trans-Neptunian object after Pluto, but it managed to evade detection for many years thanks to its unusual orbit, which lies out of sync with the solar system's ecliptic plane. At this moment in time, it is over 50 astronomical units away, near the outer edge of the Kuiper Belt, which is about as far away from the Sun as it gets along its journey. Analysis of its spectral data revealed that its surface is most likely covered in grains of frozen methane. There is also evidence for small quantities of nitrogen ice, but nowhere near as much as on Pluto, indicating that it has lost its nitrogen over time. The presence of methane and nitrogen together suggests that the world may have a transient atmosphere like Pluto. If so, this would explain the nitrogen depletion. Because Makemake is particularly small, it cannot retain its atmosphere when it expands, especially the nitrogen. Methane is lighter than nitrogen, but it freezes at much higher temperatures, meaning much less methane thaws when exposed to the sun. Nitrogen, on the other hand, is easily excited by the sun's light, and only the difference of a few degrees causes it to sublimate into a gas, where it is lost to space thanks to the low escape velocity of the dwarf. Makemake also has a tiny moon, nicknamed MK2. Like the others, it is thought to have formed from a collision, but unlike its parent, its body is as dark as charcoal, perhaps because it is simply too small to have been able to retain its reflective ices, which sublimated and escaped into space long ago, along with Makemake's nitrogen ice. I don't plan on doing a Christmas video this year, but because it's December, here's a Christmas themed minor planet. Arrokoth is a small solar system body, about 1.5 billion kilometers further from the Sun than Pluto. It was discovered in 2014 using the Hubble telescope at a time when the New Horizons team were looking for one final body for the spacecraft to visit, following the completion of the Pluto mission the year after. Arrokoth isn't anything special, or at least it seemed like it back then, and it was thought to be nothing more than a large asteroid. but it was selected for the New Horizons flyby because it was the closest and easiest object for the spacecraft to reach given its trajectory and fuel constraints. As such, Arrokoth is both the smallest and most primitive object ever studied up close by a flyby. However, when the probe arrived, it found something totally unexpected. Arrokoth is double-lobed, meaning it has two rounded segments which are connected, and one happens to be larger than the other, and so it appears like a snowman, albeit a very flat one. We're not sure how Arrokoth came to be like this, but the two segments probably formed independently, nearby to one another, before being pulled into orbit around each other, eventually connecting and then gently merging. What we do know is that the body is very red, redder than Pluto, and in fact it is the reddest body in the outer solar system discovered to date. This redness occurs over time when the surface minerals of a body are zapped by cosmic radiation and ultraviolet light from the sun, indicating that it is both ancient and well preserved in its primordial form. Its composition differs wildly to most objects explored prior, with scientists finding evidence of methanol, water ice, and even organic molecules from the data. In any case, Arrokoth is by far the oldest and loneliest snowman in the entire solar system, as it takes its solitary 293-year periodic orbit around the Sun. Dwarf planets are truly remarkable little worlds. Who would have thought that such complex processes, temporary atmospheres, ring systems, and even tectonic activity would be playing out so incomprehensibly far away from the warmth of the Sun? We certainly didn't expect it before we reached Pluto, and as is usually the case with space exploration, what we found when we arrived completely blew our ideas out of the water. And with nearly 800,000 small solar system bodies out there, just imagine what else could be hidden in the recesses of the Kuiper Belt. Contemplating such ideas makes you realise just how vast, detailed and intricate the solar system really is. And that's just our star system. Imagine what else could exist in the galaxy. If ours is anything to go by, then dwarf planets probably vastly outnumber the planets of the galaxy, and they are more resilient and complex worlds than we ever thought possible.